This episode is brought to you by ARCAT. Visiting Chicago for Greenbuild in November? Check out ARCAT at booth 529. This year's theme for the Greenbuild convention is Human by Nature, focusing on sustainable buildings and practices that are accessible to everyone. Did you know you can use ARCAT to find lead data on building products?
ARCAT's powerful search engine can help you find the product information you need that meets your environmental standards. Best of all, it's free. Check out arcat.com, that's ARCAT.com today, and visit them at Greenbuild, November 14th and 15th at booth 529, where you can find more information. Thanks, ARCAT, for sponsoring this episode of Archispeak. Welcome to Archispeak, the podcast that talks about what it's like to work in the profession of architecture. Welcome to episode 155 of the Archispeak podcast. I'm Evan Troxel.
And I'm Cormac Phelan.
And Neil's not with us this time, but we recently had the opportunity to join some very special guests on this episode in their studio in New York City, and that would be SHoP Architects. And we had John Cerone, who is their virtual design and construction leader there in their firm, to be on the show. And it was a fantastic conversation. So we recorded that separately. We're recording this intro now just so that get everybody into the episode here. And it was a fantastic conversation. What did you think, Cormac?
It totally was. And I've kind of gone back to that conversation multiple times with, different architects, with our lead designer in the office, just kind of as a, interesting philosophy shift with the way that they do it and the way that we've been wanting to do things. Yeah. And I even talked with a lot of construction, like the construction manager on one of my projects, because in the episode, we talked a lot about kind of their delivery method and this digital delivery method, the full integration between the model and, construction practices and things like that. And as excited as I get just by listening to the things that we can be doing now and the things that hopefully we will all be doing in the future, I always worry that it's the adoption of these new technologies or these new delivery methods or this new construction method. I always worry about, how are the contractors going to adopt this, or how are they going to receive it? And almost everybody that I've talked to is so very excited about the potential of getting away from the paper delivery method of drawings and stuff and being able to have everybody fully integrated into the model. And we sort of talked about it, and just thinking about like what I've been doing. I'm my more recent project at Duke, and how we worked with the contractors. We gave all of our we had the design assist team members, which were steel and curtain wall manufacturers, and our precast all had the model. All basically designed and developed their shop drawings around our model, so it was like fully integrated. Mm-hmm. And it was in that process really excites me, because we're getting to a level of control and a level of detailing, and more so into that control,
right, that
really excites the quality control aspect of the project. Because a lot of times, sometimes people don't really understand a detail or something, and they just kind of wing it and do what they feel like it. And then you walk out there and like, oh man,
yeah,
this is not what I had in mind.
Right.
And they're like, well, we're kind of moved on past it. So this is something that, unless you tell us to rip it out, and it's going to cost us, a couple of months to, change and do it a different way that we really don't seem to understand. This is what you got to live with, and we all kind of run into things like that a lot.
Which is where they're really trying to change the way that they're working, right? Because they're owning
exactly
these kinds of details,
yes,
at the very mechanical level of figuring it all out, making sure it performs correctly, and then making all those parts that are then direct to fabrication, because the digital process is allowing for that.
Yeah. And what's great about it is what they're doing with that process is that they're not doing it in a bubble. They're not doing it in a void. They're fully integrated with the contractors, with the fabricator, with the distributors and stuff. I mean, they're working with so many different people to make sure that what they see, they want the project to be, actually turns out that way.
Well, and I think what's interesting is that they have come up with a way to make sure that they've got skin in the game, which is financially tying themselves to the project performance, so that they basically handcuff themselves to the project in an ownership kind of a way, so that they make sure that it happens.
Yeah, well, think about this. I mean, doing it that way and having, we all talk about, we really want to take ownership of this project. And that's more, we want, the senior staff, junior staff, everybody to kind of like get excited about the project and stuff. But a lot of times we always kind of default back to, well, if we didn't quite work this detail out, well, they'll figure it out in the field. And this type of ownership is, no, there is no working it out in the field. It is, we will work it out now because we want to make sure that in the field, it's a smooth, flawless kind of delivery. They can get everything prefabricated, come out there and basically assemble it as everybody kind of envisioned it and not kind of just leave it to chance.
And if something goes wrong, they're an active partner in solving the issue, not leaving it up to just some other entity to do that. Cool. Well, anyway, there's so much more in the episode, and I think we should probably jump right into it. What do you think?
Absolutely. Hey, let's give it a listen.
John Cerone from SHoP Architects, welcome to the show. Could you give everybody kind of a quick little rundown of who you are and what your firm is all about?
Sure. Thank you for having me, and thank you for having SHoP represented here on your platform. My name is John Cerone. I'm an associate principal here at SHoP. I'm the director of virtual design and construction, or VDC, as it's somewhat obnoxiously referred to now. We'll get more into that in a bit. The acronyms, the BIM, the VDC, all the the sort of cutesy three-letter terms in this industry. But basically, a lot of my focus at this office has been towards digital delivery. If you were to, the sort of high-level overview, and in a way that's a lot pertained to, how do we use 3D models or the environment of three-dimensional platforms to design and deliver those designs, meaning how do you make them? So, a lot of my focus, specific work, the fabrication deliverables for Barclays Center is probably, one of the most prominent physical things that people have visited. Nassau Coliseum renovation, the exterior. We're doing a project in Botswana, Africa, that involves a lot of sort of intense digital modeling for fabrication. But really the components of our design, of which every project has some feature. Often it's the exterior, the facade. But the projects where there's a relative amount of complexity or intrigue, aesthetic intrigue, but then all of that, of course, is closely associated with materiality and how it's made, and whether it's the machines or people processing that information. But all of that, how do we most directly communicate design to the people or machines making it and get it up on our buildings? That's been a lot of what my focus has been. And that leads to all kinds of, sort of strange and interesting tangents, of course, into, VR and AR, into digitizing, laser scanning and photogrammetry. It leads into a lot of the sort of fun, weird tech avenues.
Right.
But all of that is really in service to, what we think is, the delivery of great design into, to the physical world and creating great experiences for people.
So if we just kind of go back, if we dial back the timeline, SHoP was started with this kind of mentality, right?
Yes.
And so that to me is kind of like It's one of the driving, the mantra behind why you do what you do, and it seems incredibly clear. And so that, because it seems to go through all the projects. I mean, Cormac, when we walked into the lobby, right, it was there were lots of models. It was an architecture office, no doubt. And you guys have the model airplanes on the wall. Could you kind of talk about just how that whole thing started? Because I think one of the things that impressed me about SHoP in particular was just the idea of performative based design.
Yep.
And it seems to kind of bleed through everywhere in your environment.
Yeah, it definitely does. As you identify correctly, it is in the DNA of the firm. I think, a good preface to this is that depending who you talk to in this office, you're going to get a different angle of a project or a sort of story or narrative. That's, I think that's one of the sort of richness of this office is that it is a place where a lot of different interests, whether it's materiality, whether it's environmental performance, whether it's, digital modeling and directive fabrication techniques, you're going to get a different area of focus, and meaning a different sort of story of the project of what's valuable about this project in the eye of the presenter. And I think that's a really important part of the office. We're not all here, coding parametric design. My angle is always the digital process, so it is a tech heavy approach, which is what the sort of bias of what you'll probably hear in this conversation today. But there are people that are equally focused on the touch and feel of material and color contrast and this sort of experiential design and all of that. It's in SHoP is a synthesis of that, of what something looks like, feels like. The experience can't be separated from how it's done. What is the material? What are the properties? What is the tooling required to do it? So it is this sort of equal part artistic and technical approach. And I think it's just important to preface it with that because, again, not everyone is doing the same thing or everything here. It's a really good blend and synthesis of different backgrounds and interests coming together to deliver, the one thing we all do care about is again, delivering great product, a great built environment for people. So, to that point, the technical side of it, I think, which we get into, you identify the planes and sort of the DNA of the office. It is relatively straightforward and it is potent. We think the narrative, it came from, the partners all came from different backgrounds. I think they were not architectural undergraduate students. They came from history, art history, finance, structural engineering. They came from different, walks of life. And as they say, their midlife crisis decided to, apply their focus into architecture. So they all went to architectural school later in their educational careers. And, it was a time where, Silicon graphics and 3D modeling was sort of hitting the design floor.
Yeah.
I went to undergraduate in Miami of Ohio, where Form Z was the 3D du jour. I think it still might be.
Yes.
And then
I'm the same vintage, so
yeah. I love Form Z. It's like a very clear. I wouldn't get into that stuff, but as a 3D modeling tool, like it's very explicit about these are points, these are lines, these are faces.
Right.
But so I think I take that for granted in the sense that even in undergrad, that was kind of a new approach, the idea of 3D modeling. I think this is, and then of course, graduate school later at Columbia, it's a very 3D heavy approach. But I think when the partners were in grad school, it's sort of hitting the design studio, and I think you get a lot of blob, you get a lot of formal. We can make shapes we hadn't been able to make before.
Right.
and I think a lot of emphasis was put on render and image and
Yeah.
experimentation in just digital form. And the background, I think the interest of, to their credit, of the partners, there's a very aerospace focus, there's this kind of infatuation with planes and marine and automotive industries. And the 777 documentary of how this Boeing is putting the advanced technology, the first fully 3D digital CAD of a plane, that's coming out at the same time. So while architectural school of thought, a lot of it was kind of graphic heavy. Meanwhile, in other industries, there's these huge case studies of what you're able to do, digital mock-ups, and how the 3D model is this platform that can deliver high-end engineering and fabrication. So the partners, I think, were focused. Their ear was towards the kind of the Nova Special, the 777,
Mm-hmm.
and this technology hitting on the design floor is like, okay, we've got these 3D modeling platforms. We can use this to make stuff. And I think that was a very clear idea. And, it comes in the first projects where you're, it's sort of raw digital exercise, but it was always about extracting, not just making a form in 3D, but making that physically. And how do you use the computer to translate the instructions to make it? So I think they felt that, if looking at these other industries, aerospace, automotive, architecture is heading down the same path. And when we graduate here, we're going to enter this industry that's putting buildings together the way Boeing puts planes together. And obviously there's a rude awakening when
Right.
Yeah.
hit the professional, hit the landscape. And the reality is a lot of this industry is still working the same way for thousands of years.
Yeah.
So that idea that, wait, other industries are using this technology to have it really high-end control of both the engineering, the simulation, and the making, the fabrication of their parts and components. Can't we manufacture architecture? Can't we deliver design the same way? That is the absolute core of the DNA, and it is simple. It's profound in the sense that I think it resonates so well with, I think, students and professionals, that I think SHoP had a lot of acclaim. The proportion of acclaim to actual built work at the time was, there was a lot of the story. And because it's so true to the DNA, as we worked on and developed bigger and larger scopes and projects, the way we deliver them has stayed true to that initial DNA. And it's in a way, it kind of exponentially charges itself. The tools get better, we get better at using them. We'll get into the softwares we use, but we're well outside of the realm of traditional AEC tools, and it's scaled in a way that we're able to actually deliver really large scopes in the way that we had always wanted to. It's always a continuous evolution and education, obviously, but that's certainly a compelling story of SHoP.
Mm-hmm.
Is of the DNA. It's certainly why I'm here. It's my specific area of interest.
I think some things that kind of stand out to me is, number one, there's like a primary drive to make physical things, right?
Yes.
So it's not just documenting a design. It's really about making the thing.
Yes.
The second thing is, let's get as much information into that model so that the thing can be made exactly how we want it to be made, which requires a high level of ownership over the process. And I think that's something that is a little unique for your guys' operation, because it seems to me the trend over decades of architecture is, okay, first of all, let's just figure out new ways to do the same thing we've always done, which is draw lines on paper, but also shed risk, right? Give it away, get rid of it. And I think one of the things that I keep seeing every time I think about SHoP or what I experienced walking through the office, and Cormac, jump in here. I mean, I felt like the ownership is high because you guys are willing to take on figuring out how this stuff's going to happen. And I think that, like I said, I think that's a little bit unique.
Yeah, I mean, we certainly are. We feel that way. It's we think it's a necessity. We want to no one entity can't transform an industry, but you can certainly help. You can be part of a movement that hopes to kind of evolve practice and how as designers, your sort of authorship and ownership of scope and how you collaborate, really intimately collaborate with experts. So we're not fabricators. We're not. We certainly don't pretend to know all the ins and outs of factories, and we don't tell our subs on a project how to do their job. But we have a digital platform that just really enables deep collaboration. So we're good at digitizing, automating, geometry, and we have obviously we drive the design intent. So when we work with experts, whether it's enclosures or wood systems or the people making the at the end of the day making the pieces and parts, and we do think of our projects. Maybe that's unique. This is a very simple statement, but somehow it seems to be kind of have a deeper meaning. We do think of our buildings as pieces and parts and assemblies. That's kind of an important distinction. It's not just sort of large masses and geometries kind of colliding in some unknown resolution that you sort of wait till shop drawings to figure out how things go together. We do like to think about resolutions of detail that support design intent. And then when we collaborate with the people that are actually engineering and sizing, thicknesses of plates or mechanical connections, we already have a backdrop or a infrastructure or environment, a digital environment that allows us to explain what we want, what we're looking to achieve, and then also, dial in or represent the fabricator's constraints and logics. So we're basically able to sort of simulate those systems and quickly, automate them, see what they'll look like across the scope of the project. But it's really a way to sort of internalize the constraints from many different, whether it's engineering or the actual material fabrication standpoint or logistics of shipping. We're able to take all the constraints and kind of incorporate that into our design inputs in a way. Mm-hmm. So it's not, there are certainly areas where we've taken on more risk, where we actually provide cut files and things like that. But at the core of it, it's really operating an environment, this sort of digital platform for collaboration. So do we think as these platforms evolve that architects will be making cut files in the future? Is that the future of design delivery? Not necessarily. We've done that as a sort of stopgap to when someone said, this is too complex, or can't we just rationalize these, there's 12,000 panels, can't we just rationalize them into 8 different sizes?
Right.
That we have engaged in levels of modeling and fabrication to achieve a design that we know is achievable. But the future of this, as this evolves and more contractors and fabricators come into these 3D platforms, and the machines direct to manufacturing becomes more commonplace, we see our design model as a place, as sort of a replacement to a lot of the traditional processes. Why do we do a design model, give that to someone else, they model their system, send it back to us in drawings to review, and try to catch all the
Right.
the three-dimension, as things turn the corners and try to trace the details around Imagine in 3D, where we end up modeling it ourselves. Like this whole modeling to translation to 2D for distribution, and then people remodel that to what they think. It's kind of this strange game of telephone, and it's not efficient.
Mm-hmm.
And as people become more comfortable in using the 3D environment to make, we think we'll be trading models back and forth. We'll see people's models evolve within our platform. It's just this kind of real-time collaboration. So that's the excitement.
So let me ask you this, because now you just stepped into, this is a soapbox that I've been pulling out multiple times to basically beg and plead people. It's like, look, when we're designing for a 2D output, because in a 3D world, of course we're going to have change orders. Of course we're going to have all of these issues and things like that. And where I was going with that is I was curious about what your experience with your contractors and fabricators and stuff have been with the dialogue back and forth, and just staying purely 3D rather than waiting for that cyclical, I'll do it in 3D, then 2D, then 3D, then it comes back to us in 2D kind of thing. I mean, how have they been?
Is there like a sense of relief, or is there pushback?
I think it depends on how it's set up and how you're kind of entering the project. I started by VDC is this sort of obnoxious term that's come out as a focused version of BIM. So like building information modeling, it meant something. I think when people sort of you've got a three-dimensional representation. It has information attached to it, and that is your platform. That's the project, and everything is represented. 2D is an extraction, but it of a 3D truth. And from BIM, I think we've entered this. BIM is a requirement. I think it's become super generic, and every contractor, every design, we're full BIM. We all BIM. To the point where I don't even think in lectures and in the office we don't even say BIM. It's kind of like, unless we're sort of joking, because it's so generic to a point where there's validity in the idea, of course, but digital models and how they're used, we like to be really specific internally. Like what is a point cloud? If you do a LiDAR scan, how does that get into meaningful 3D geometry that we can measure off of or coordinate a fabrication model? How you're using the model and how you're interfacing with a 3D environment is really important to be specific. And then when people are we're BIM everything, you find that it's not. I think if you were to go into, a lot of people are modeling, as you just said, are modeling for 2D deliverables, which means a lot of things are skipped,
faked,
or coordinated, or 3D comes afterwards as a deliverable because someone wants BIM and no one, it's not specific why they want
just a checklist. It's part of the checklist.
Checklist item. And that, unfortunately, a lot of I think the industry and the sort of, as you said, the wanting to shed liability has backed a lot of this into the corner. I think specifically in the States, where people are even reluctant to share 3D CAD because if we had, we didn't resolve this corner, someone's going to go and use that as a, they're going to build off that, where really the 2D is what the actual deliverable is. So what's in our PDF is what you should go by. And, there's a lot of this kind of confusion.
But still don't measure off that, right? Like there's still all the disclaimers.
Exactly.
So, to your point, we've, since, the kind of Barclays to Nassau project, the workflow there was really reassuring, because I think we pioneered a lot of, and it's interesting, the lineage of the firm too, because you start with the idea that a computer you can make something in the computer and you can use that model to make the thing. So, PS1, which is this initial pavilion, you look at these evolution of projects. So the early projects still all had the DNA of, can we create one-to-one jigs? You've got like PS1 and camera obscura, and you couldn't have done the porterhouse project without proving a sort of a way of working on those initial projects, that sort of DNA.
You're always building on that to get
Exactly.
to where you are. So yeah, it's not like you guys walked into this with all the knowledge. It's been a build up over time.
Exactly. And then, you can't do Barclays had you not done Porterhouse. And Barclays is kind of, the idea that you're going to do the cut files for, a rain screen system, which was the Porterhouse, and actually as a designer control that deliverable, that is somewhat unheard of at that time. And now, of course, I mean, there's I think firms that look to do that at that small scale. But then when you look at Barclays, it's just an exponential increase of complexity and resolution. But it's done in a way, it's the exact same mentality that we're gonna digitally mock up the entire project and use that for the deliverable. And of course, the tools, scale at that point where, you go from SolidWorks, Rhino, SolidWorks, up to kind of CATIA, full-blown, fabrication models at Barclays. But we proved that was one where we formed this relationship. Forest City is the client, Hunt Construction is the builder. It was a design build, and we're working, directly with a facade fabricator. And you build this relationship where, the project is so complex, the timeline is quite tight, the stakes are very high, and there's this realization that the model, we're coordinating primarily through 3D, fabrication models, and you form this relationship where reviews and design reviews and sort of logistic studies are all done around these models, and stuff fits. The work instructions out in the field are screenshots of a model, or in some cases, us with an iPad or a laptop, spinning the model around to say, hey, we've overlaid the laser scan of the structure here. The facade units are coming in from fabrication from another place, but the laser scan shows that this plate was installed incorrectly or is damaged. So you're going to have to notch this out before you install this facade unit. And we're doing this all through like model. There's no written directive. There's no sort of PDF documentation. And the initial feeling or response to that from the contractor, from the foreman on site is like, you're out of your fucking minds. Like this is crazy. You're telling me to go through and cut the steel or move this plate or do this from, this sort of three-dimensional.
And you're like, yeah, I'm trying to help you.
Yeah, no. And what's funny is, the first, as the units come in and they start installing this and they realize like, oh, like that.
Yeah, we're right.
That wouldn't have fit.
Yeah.
And, I remember like the first unit of like the canopy of Barclays, for example, it's this sort of alien object that shows up. There's 5 hooks that are in like weird locations. There's no drawing to show like where it goes. And it's just with the model, you say, you know what, this unit goes up there. And they're like, well, what are you talking about? Like, well, there's 5 hooks. And then if you look up there, there's 5 pins that are all like specifically located. It's kind of this bespoke system. And they're like, well, so we're just supposed to lift it and it'll fit in. You're like, yeah, that's the idea. So they I think there's the initial reaction is to be obviously skepticism. And they're like, oh, this is crazy, but whatever, let's give it a go. And they lift it up and it like fits perfectly into place. And they realize, as you move through, had they not, notched this plate or adjusted this pin, that the stuff wouldn't have fit. But everything starts fitting and locking into place. And to a point where the skepticism turned into like it was actually fun. Like we'd go out on site and the foreman is like, all right, well, what do you got for us today? Like, what are we doing? And they go from installing, 1 or 2 units a day very quickly and installing 10 to 20. It becomes this
You
kind
guys,
of game.
you guys
And they
gamified it,
become,
yeah.
yeah, exactly. They become sort of involved, and you show them you can review digitally an area, this something needs to be resolved, and they kind of feel ownership and stake in this now. Like, oh, we could move this plate, we could switch this bolt. We need, on our end, we need to get approval from engineering for that to happen. It's the digital model. You sort of make the adjustments in the model, send screenshots, the engineer runs calcs, sends it back, and it's just this incredibly efficient mode of communication that everyone is involved and has their head around. So
it sounds to me though like you guys,
yeah,
there's this huge process every time you work with somebody new that you have to kind of go through this process
absolutely.
with, because that distrust or whatever you want to call it has been built on this history. Have you guys ever thought about doing like shop class or whatever you'd call, what would you call it? But something preemptive to the project starting construction to talk about that kind of stuff, or do you just always do it once it's begun?
Yeah, I think we do the orientation. I mean, I don't think that can ever prepare people really for it. I think there's always going to be a level of skepticism.
Because it's not real. Yeah.
Yeah, it's just, like it's not real. This is not how things are done. And I think when you do it, all of a sudden they realize it's really real. And it's actually in many ways, there's so much truth in these models. Yeah. For better or worse, you expose, look, that you're going to have an issue. This facade unit is going to hit a structural bolt. Like we've got to do something about this. It's not something they find out once they've lifted the unit in, which of course those kinds of change orders are just a disaster for schedule. And when you do the traditional approach, which is, all right, something didn't fit, why? You go through this exercise, you go through drawings, you go through design intent models, you go through shop drawings, you go through all this sort of different modes of communication, and that takes a lot of time.
Yeah.
And meanwhile, that time, people are doing stuff. They're going to cut things out. They're going to make something fit.
Oh,
right.
Man.
And
right.
that is
the detriment of the project.
That's a danger.
Exactly. And it can snowball. So it's kind of this, when you have this level of this model, this kind of CAD that is a federated both sort of design and fabrication model, you can get an answer very quickly. Like if you digitize what's there and you know what's built and is intended to go there, you can make decisions very quickly. And that's often the real value of working like this.
Yeah.
And the extension after Barclays, the gang got together again for Nassau. It was kind of this process where we've already established, in a way, a shorthand, and it's not to say that authority having jurisdiction is left out. Their documents are shortcut. All the necessary requirements are there, of course, for permitting and all of that. But the internal design team and contractor and subcontractor, when you all speak the same language and we understand we're going to be trading these, you'll take our design model, you'll build your fabrication model off of that. We'll do the shop drawing, and I'm using air quotes now.
Right.
Skype. The shop drawing review is us receiving your fabrication model, turning it on and off to the design intent model. That's the review process. You all of a sudden go from hundreds of pages of sort of what we've considered a formality of these shop drawings down to intent. It describes a system for stamping, but the true review is of the three-dimensional geometry, and it is you can replicate it. And I think in that experience, we're working with Hunt Construction on when we did that with Nassau. They brought in Crown Core, which was a subcontractor for the facade that very much spoke the same language, and their subs, the people doing the fins, the people doing the space frame, everyone spoke that same language, and it's just the efficiency you're able to achieve when that is the sort of common language is incredible, and we do see the industry inevitably moving that way.
Right.
It's this process when there's a new a new project and a new team involved. We're very on purpose. We try to be very open source with what we're doing and how we're doing it. We we don't have secret modeling techniques that we won't share with a fabricator. If they want to sort of see the scripts or sort of see how the sausage is made, or you want to. I mean, a lot of it's like sometimes it's TMI. Like there's just like, okay, we're not there yet.
Right. It's
But
overwhelming. Yeah.
it's overwhelming. But you have to show how their rules are being embedded into your automated
Yeah.
models.
You have to show the logic behind the system
Exactly.
so that trust is yeah.
Exactly. It validates the process and the trust is there. And that is something we're very open to share always, because that's not specific IP. It's a way that we hope that there's a continual evolution towards working this way.
I have a question for you that I want to kind of tee up real quick, because we talked about this on one of our previous episodes as well, just talking about the model-centric workflow and how it enforces or requires honesty in modeling.
Yep.
Because
garbage in, garbage out.
Right, garbage in, garbage out, or you're back to the old days of having to coordinate all the different drawings if you're faking stuff on one because you're faking it in 2D, and then all of a sudden something changes and you forget to go to the other views and update it because of that dummy crap that people put into models. Yeah. So I think that everything that you just said kind of speaks to validating the reason behind enforcing that honesty. And I wonder if that's a conversation that you guys have, or if it's just inherent in the way that you work. But then also, what do you think, my question is, what do you think is keeping architecture as a profession back from jumping more headfirst into adopting the model-centric workflow? Like, what are the things out there that are, because I don't think it's necessarily the software. I don't think it's the software vendors. We're always maybe asking for more in that realm, but in the work that Cormac and I do, a lot of times it's the agency review. But besides those, like, what are the things holding us back?
Yeah, I mean, the deliverables are, that's still it. You're right now responsible for construction documents and specifications. I mean, the deliverable now is two-dimensional. That's industry standard. That's what contracts are focused around.
That's what the AIA believes in, right?
Yeah, and then the other side is liability. I mean, I think people don't want to overshare. If that's the deliverable and that's the accepted deliverable, giving a model that may or may not sort of completely sync with that 2D deliverable. I think people like the gray area. I mean, not that they like it.
It's a place to hide, right?
You hide. Drawings you can hide in 2D. And
right.
So I think a lot of it, in terms of architecture offices, we certainly have to address this. Like, there's a certain part of the way we model. It is a very 3D heavy firm, and not in a kind of novelty way or kind of a gimmick. We design in 3D. Where design happens in Rhino. We use Rhino and Rhino Grasshopper. Like, we are. Right. I say that synonymously because I think we do have a very high level of proficiency in Grasshopper and sort of parametric stuff. But design happens in Rhino Grasshopper. It moves into Revit for documentation, and then often it gets paralleled in CATIA for potentially some advanced systems and modeling. But we deal with it because it's a resource issue. If you still are responsible for the 300-page construction document set and hundreds and thousands of drawings of details and the model, something has to give.
Yeah, I was going to ask you guys actually about that, because you are so willing to take on, in order to get the thing built that you want built, you're so willing to take on these different responsibilities. To what cost does that affect SHoP?
Yeah, I mean, it's a thing here for sure. I think the projects where we've done it, it certainly wasn't for, it wasn't for profit. It was for,
quality control.
Quality, getting, the design we wanted. It has not been a profit-driven exercise. But that said, we think there are versions of this model where there'll be innovation in terms of how you write the contract and how can we deliver a design model potentially that has that we're able to deliver useful CAD.
I mean, I bring it up the way I say it because it's it's on everybody's mind, right?
Yep.
It's going to take so much of our time to develop the things to this level of detail or to this understanding.
Mm-hmm.
Maybe we need to get educated on how to do this stuff. That takes time. We need to talk to the fabricators. We need to become educated on how they do, what their machine limitations are, what the transport limitations are, when typically we've offloaded all that kind of stuff. So there's definitely a cost, but you guys seem to be working back toward the master builder kind of idea. And so like you said, you're not doing it for profit, but you're doing it because you believe in something. And that is more important than the profit.
Yeah, I mean,
not always, maybe, but a lot of times.
No, I mean, we are, we are
have to make profit.
A for-profit enterprise. I mean,
right.
we're this kind of both and that we always start our lectures with. We're both in this sort of R&D and academic thinking, but we are we're a production firm. We have to make the buildings that we design. That's both are valuable, and to do that, I think we have to be realistic about efforts. What's interesting is you have to be realistic or keep an eye on the global sort of landscape of this industry. So it's interesting because when you work this way, there are incredible efficiencies to be had in terms of like time and effort. You're able to do large amounts of work with small concentrated teams. So there's a way that this can be negotiated that I think it is very profitable for everyone. There's kind of this win-win-win situation where the building, if it's done at this, if you can design and deliver in an environment that's this efficient, the building will be cheaper because there's less kind of gray area change orders. The contractors will be more efficient in terms of time, and designers will potentially make a little bit more because they're in control of deliverables. If you invest a little bit more upfront to make sure that there's meaningful CAD, there's meaningful documentation, that you hand the baton to the contractors, manufacturers, that whole timeline compresses. And there's a lot of efficiency to be had there. To overcome that, I mean, it's a beast to overcome. I mean, there's so much contractual language and kind of historic, this is the way things are done. There's a lot of inertia or a lot of sort of like mass
momentum
to move. So you can do it through case studies. I mean, certain events we had or certain experiences we had on these projects, Barclays and others, for example, where it's just this extreme level of this was the design, this is the representation of that design, the steel detailer takes that CAD, uses it as the backdrop to their fabrication models. It's so efficient that we know, like, you can't unknow that.
Yeah.
So we know it exists. It can work, and then the real innovation will come from client design, builder contracts that allow some of these efficiencies to work. Because we said, it's not efficient if you have to do all of it. If you still need all the drawings and documentation and the modeling, I think it's a bit of a misconception that modeling is harder than drawing. It's a reappropriation of effort.
Sure.
Right.
But right now, if you still need all of the backgrounds and the drawings, you don't have time to you're spread thin.
Yeah, the balance is a real thing. Yeah.
Yeah, the balance is wrong. So that we hope that there's a shift in that kind of mentality.
We were talking about probably one of the bigger things, because I see, just in my own practice, I've seen, not my own practice, but what I'm doing with the firm I'm in. I see that a lot of the contractors, precast manufacturers, whatever, are actually working as design assist with the models. So the steel contractors and everything else, they're all working with your models.
Yeah.
And so there's a good dialogue coming up. The electrical engineers, the subs, everybody, they're working with the models. But we think the bigger hang up is really with the AHJs, because they're not really equipped to understand what we're doing with the model. And so we were saying, I jokingly said, well, we're going to have to wait for everybody to kind of die off and then have a new breed of AHJs come in who are tech savvy, that understand, the softwares that we're building in, designing and building in, to basically move that forward, so we're not just doing the doubled effort.
Yep. And I mean, this is exciting because this is where something like, virtual reality and augmented reality, beyond the novelty of it,
right.
we've been very deeply involved in it for several years now. And less about I think the obvious use of VR is like, hey, clients, here is the finished space. What do you think? Or, hey, client, here's the finished space. You can, sell condos. This is what it'll look like. Yeah. You can, it's a marketing tool, and it of course is good for that. But I think our interest in VR has been much more like the implications of it on our industry. Mm-hmm. That's exciting to us. So we use it in very early stages of design. And of course, we do use it for, here's the final materiality, or, this is, you get that kind of immersive rendering. But we use it, the interesting parts are way before that in concept. Agreed. Even, concept through schematic. I mean, we review things genuinely, review in VR.
It's the new way to redline a set, right?
Yeah, which makes perfect sense. You're building, the ultimate goal of this is to have a 3D building that is occupiable for people to walk through. So why not do this throughout the entire process?
Yeah. So the more you have to do stuff for VR, we like it because in a way it's this, it's this. I don't mean this in a malicious. It sort of undermines the 2D. You need to review it. It's in 3D. It's conducive to this 3D environment.
Absolutely.
Like this is the way that the AHJs can, the authorities can review this way. Like it is, in a lot of ways, it is actually, it breaks down barriers of CAD navigation, because even the most, like the simple, all you have to do is right click and move the mouse and it'll spin this model. That is foreign to people. But if you just look, you're in it, and just point to stuff and click, there's no barrier of entry there. And we can get people that are expertise, the code officials and fire departments, you can get people engaging the project, which is a 3D thing. Then if you get them used to these environments, then you can start asking the question, do you really need this piece of paper to approve it, or are we good? That's the way it could eventually happen.
Right. I mean, as you started talking, and we were talking about getting the HGAs to basically do VR, I'm envisioning, because, I'm getting to a stage in schematics of a project I'm working on where we're going to be sitting down with the fire marshal, walking through it and everything else. I can imagine taking him through and saying, okay, here's how you enter the building, and let him enter the building. Let him walk to, where the fire enunciator panel is. Then let him go, to each floor and understand, where his standpipes are, where, all of these like little minutiae that he needs to worry about actually are, and say, okay, yeah, this makes sense. No, I think because of this, once he gets a spatial understanding of things, he's like, okay, you need this to be here, because it's more adjacent to your stairs, or, I'm just throwing stuff out now. But, you know what I mean? At least he's engaging in the ability to understand the building.
Yep.
And even beyond that, you can take, because it's just a 3D environment, you can make any view you want of it, right? So
right. Yeah, if you
could easily just put a giant marker everywhere that these things are. It's not like the days of here's the plan that shows where the standpipes are. This is a view specific for an audience that matters to them. And we have the ability to do that, but I think for the most part, most architects aren't doing that kind of thing.
And I think to that point, this is all. It's a compelling, and we believe it's inevitable in terms of the sort of design and review process, the permitting. That one of the things that's sort of held some of this back is we still need the drawings to make it. So AR, like a contractor isn't going to pop into VR to figure out, where they should lay out the studs. That's sort of a little unrealistic. I mean, they can walk through, you can coordinate logistics in that sort of immersive environment. But AR, which is at a very sort of nation state, we understand that. But the implications of augmented reality, where in the physical world, the overlay sort of holographic instruction manual is there. We've been experimenting with. We're using HoloLens now, but this, there's technologies coming out where like that. Once that becomes sort of understood or meaningfully applied to sites, that's a direct case for three-dimensional deliverables. Because whether the architect is whether it's coming from the design model, probably not, but it will compel contractors to create meaningful 3D CAD that you can build from, because to overlay that in reality, as a augmented instruction manual, that level of coordination is required, and that can be incredibly efficient. I don't think anyone will care about a two-dimensional representation if you're able to convey that sort of in real time in 3D.
Yeah, agreed. One of the things that has come up that I've seen is, because on 2D drawings they're sealed, right? There's a stamp in the corner.
Yeah.
That says we take liability for what's on this page. In a 3D environment, that's a little different, right? Because that isn't really a thing. But I'm just wondering, maybe this is where the idea of blockchain comes in, where you've got a ledger system that is built in so that the different entities who touch the model have accountability to it, right?
Absolutely.
The technologies are out there to do this kind of stuff, but and they're not necessarily happening in the architectural realm, but they are happening where it could be applied to it.
100%. I mean, that's obviously the challenges that we sort of face in terms of ownership and who's the kind of collaborative IP or life cycle of a project. Other industries have been dealing with this in 3D CAD for a long time. I mean, this is where when there are ways, and in certain ways, it's even more explicit in terms of this is the geometry, the sort of design intent that we are responsible for, and it might be surfaces, it might be lines or points that this is the intent, this is what we care, this is face of glass, this is face of curtain wall, and we understand the details behind that, but we'll own this surface, and what you build off of this surface as an input is your model. We see it all in one environment, but very explicitly who's done what is, timestamped to each move, and the models belong to the trades responsible. So in a certain way, it's even more kind of explicit. There's no kind of opacity to that. It's incredibly transparent. I think a lot of times maybe people worry about that transparency because, as we said before, you can hide it in 2D drawings. So there's a lot of maybe money to be had in change orders, or we'll figure this out when we get to the field. But the idea that if everyone is working in that environment, our inputs are very clear. There's surfaces, there's indicators for material specifications, offsets, things like that. But how someone builds the system would be represented or built by the people ultimately responsible for that system.
Right. I think what's and maybe you could just comment, when you are working, this kind of goes back earlier in our conversation where you're working with these different fabricators. When I was teaching an emerging technology class in the architecture department at our local university here, and one of the guest lecturers that I had, she was talking, they're doing direct to fabrication digital modeling using control surfaces, but then backing it all up with the structure and all that kind of stuff. And they're working with fabricators who love this idea. Right?
Absolutely.
You're not pulling teeth to get them to do it. And I think the reason I wanted to bring this up was, I think a lot of times architects compromise before the thing goes out the door. We've talked about this on the show previously, where we make assumptions based on maybe somebody's previous experience or how we think it might turn out. And what I wanted to maybe get your input on was, give us an idea of what it's like to work with some of these people who are like, give me these these
Yep.
juicy ideas to take and run with, versus the constant pushback that we get kind of in today's construction mentality that we're seeing on job sites and stuff like that.
Yeah, I mean, I think we have examples. We have one currently, which I don't know that I can say what it is specifically, but where a fabricator's like, look, why this is incredible. You could give us stuff we could use. Like this could be, and we'll figure out the sort
You're
of
doing our
details.
job for us. What?
Yeah, or in conjunction, you know what I mean? Like I think a lot of times architects overdraw stuff because we like the
yes, we do.
we think we know how it's going to go together, but the reality, I mean, there's design intent, which is we do care how thick something is or the sort of reveal between one material and another. But the systems behind that, we're often, that's not our area of expertise. It's not our that's not our scope. But we like to draw the stuff, and it's all for pricing. So one of the big challenges, which we hadn't mentioned, the design bid build, it does pose a challenge because you don't know, like the idea of a design assist lends itself very well to this way of working because people get their eyes on it. The systems, whether you're modeling it for them or they're capable in modeling it. You are working in this kind of federated design environment. It is more challenging, a design assist. This is where parametric modeling, it helps because it can adapt. Like you could say, all right, this is bidder one's version or bidder two, or ideally, here's the surface. Bidder one, impose your model on this, or like use this surface as the input and build what you would do. Bidder two, same thing, and we can comparatively review, contrast the different systems and approaches. And bidder 1, 2, and 3 wouldn't necessarily see the others' systems in place, but in one model, you could, like, there are of course technologies that allow for this kind of like black boxing. Like one person can see this, you can't see the other person's connection detail. Like all of that has been managed by aerospace for decades. So the idea that you could actually create a meaningful review process, a bid process in 3D, like that's not unreasonable at all. And the fabricators, certain ones, love that idea of here's basic surface areas, take this, do what you need to find quantities, do what you need to sort of descope the project. But if we could review, if they built their systems on it, that would be incredibly efficient.
No, absolutely. Yeah. I mean, because then real time they can start to, say, okay, well, I'm bidding this, electrician comes in, I'm bidding this raceway in here, and I see that we're going to have some conflicts there. So, they, maybe add a little extra to their bid or something to kind of like work through some, coordination issues or things like that. But I mean, I've been having a lot of experience with this recently because the last project that I've been working on, which is under construction, it was a design build. Not design build, but it was a design assist project. Mm-hmm. And, we didn't have all of the trades do it, but all of our major systems, our HVAC, it was a precast curtain wall, steel building, and all of those major trades, all design assist, and they all built their own models. Foundations, built everything. So we could see where the duct banks were coming in and conflicting, clashing with our foundations and things like that. And it just made for, I remember traditionally reviewing above ceiling or below grade drawings and, having to go back and forth with them and things like that. And, to be able to just sit and see everybody put all of their stuff in and spin the model around. Yeah. Oh, crap, I got to drop that footing. Something like that, it just makes it so much easier.
It's amazing. I mean, you have the information. You're sitting in a room, and it's like there. So this thing's hitting this thing. So this one, trade A is hitting trade B's thing. We can sit here and we can have a reasonable discussion about,
what do we do?
Either this beam's going to move up or that duct is going to dip down.
Or Mr. Architect, can you drop the ceiling?
Yeah, or exactly, or it's. Or there's no room for any of it, and right, architect, you're going to lose 6 inches off your ceiling. But that, you can, when it's in front of you, you can have, I think the collaboration is so much better. People are invested in the process and the project. it's sort of more enjoyable, which is something we never really talk about, that like designing buildings and navigating this sort of rich 3D environments is more fun than
Right.
drawing sort of 2D representations of it. It's just
yeah. I mean,
it's fun.
How many times does a client ask you, it's just like, well, what is it going to look like? What is this space going to feel like? And how many times do they get confused when you're looking at a 2D printed view of it, and they're just like, I don't understand. I mean, what do you mean? And then you have to say, okay, well, picture this space here, and you're like, pointing at, like it stops there kind of thing. But if you put, going back to like, VR, I mean, being able to immerse them into this space, and they're like, oh, okay. And
again, it enforces that honesty, right? Because it's not it's not the wide angle lens with the lens flares and the soft glow on the highlights and all that stuff. This is what it is. I mean, and you can look anywhere you want, and that also kind of again just reinforces that there's an inherent honesty to this process, which is a good thing, because everybody gets exactly, you set the expectation.
Yes. I'm really glad you went there with it, because I think, honesty is a incredibly, that's an important, I know it's simple, but it's a very important idea to pull out of this, because, I think one of the best compliments SHoP receives is that, when the built work is done, it's, wow, that looks exactly like the rendering. And it's like, yeah, that was
our intent.
It's a sort of testament to this process and the way we work, in the sense that like we're not going for that necessarily, but there is this kind of transparency or honesty through the process, internally too. We're designing things. We're not, because partners are reviewing things in VR, and it's all we try to keep it digitally as real and as a simulation of what the 3D environment is, because as you said before, the product is a three-dimensional industry and environment that's the goal. So when you work this way, I think that the byproduct of that is something that's very true to what the intent was, and that it's an honesty for sure, sort of honesty, integrity of process, and coordination and collaboration. Everyone sees the same thing, and there's no major aha or surprise. I mean, it's.
Well, think about how transparent you can be just to the client themselves. I mean, because we frame views for them, of like specifically what we want them to see.
Yep.
And, in this kind of 3D environment where we let them see everything, the good, the bad, and the ugly, you're able to like let them know, where some of the challenges are and things like that. I mean, it does offer them that truth and that honesty. And I mean, hell, to be quite honest with you,
yeah,
a lot of times we're trying to pull the wool over their eyes just to, get them to, buy off on the next scheme so we can move on to the other one. And in this particular case, they get to see it all, and they get to understand like the reality of things.
Yep.
It's like, the reason we can't do this that you keep asking me for is this, and they can see it.
Yeah, absolutely.
Well, John, we want to be respectful of your time, so I think this sounds like a good place to wrap up. Thanks so much for coming on the show today and for getting this all to work out. Fantastic. It was a great conversation. And you can follow SHoP Architects online on social media, and you can find them on Instagram and Twitter with the same handle in both places. Very convenient. That would be SHoP Architects, all one word, no spaces, SHoP Architects. And we'll have links to everything that we talked about in this show, including all of the projects, that Boeing 777 PBS special, and everything else at archispeakpodcast.com. Thanks for listening, everybody. And we'll talk to you guys next time.
Thank you, guys. Cheers.
Thanks.
Drunk